Hello and welcome to Wednesday's edition of Cracking the Cryptic, and today we've got a brand new type of Sudoku for you, and this is by none other than Christoph Seeliger, who's one of the most brilliant constructors in the world. It appeared on Logic Masters Germany a few days ago to rave reviews, and it's actually based on a puzzle by a new setter called BigTiger. If this puzzle proves popular, I also intend to do BigTiger's puzzle on the channel as well. So do let us know in the comments once we get to the end of this video, and once you've had a try of the puzzle, whether you enjoyed it or not. Have I got any news today? Not really. Obviously our THERMO Sudoku app is out, for those of you who don't know that, and our Patreon puzzle for June, our reward puzzle, is also out. So if you are supporting the channel on Patreon, you should be able to play Olympic Sudoku now. Now, the rules of this puzzle are quite interesting, so do put your thinking caps on for what I'm about to tell you. They sound worse than they are, so we're going to go through an example after I've read them out. Normal Sudoku rules apply. Consider the first X and last Y cells of a row or column, where X is the value of the first cell and Y is the value of the last cell. Clues outside the grid give the sum of the digits where these groups overlap, or the sum of the digits between these groups. Now, I can well understand if just reading those isn't that helpful to actually visualize what's going on, so let me bring in an example here and we can talk about this. So let's look at this row first. You can see there's a 6 in the first position and a 7 in the last position. So what we have to do in this instance, 6 and 7 are greater than 9, so this causes an overlap to occur in the first 6 cells, and then coming from this direction you take the 7 cells. You can see that creates this orange region which has to add up to the clue outside the grid, the 16. Now it's a little bit easier when the numbers are lower. Look, we've got a 3 here and a 4 here, so the first cell contains a 3, the last cell contains a 4. You can see that leaves a gap in the middle of the grid, and the gap in this case sums to 14, and that's what appears outside the puzzle for that row. So seriously mind-bending variation, and you can see that in Christoph's puzzle, perhaps unsurprisingly given it's Christoph, there are no given digits, yeah, just these clues outside the grid. Now let's just play around with this before we start and have a think about how we might go about solving it. I mean, it looks like the 39 clues might be the place to start, but I just want to try and get my head round. I'm going to use a blank row to think about this. So let me just think about this. If this was a 4 and that was a 9, that would be saying we take 9 cells from this direction and 4 cells, so that's causing an overlap to occur in those 4 cells. So whatever was here would be the total for those 4 cells, including the 4. Make that a smaller digit. Yeah, okay. So that's interesting, isn't it? The 4, you can never, because there either has to be a gap or they have to be there has to be an overlap. In rows and columns where there are clues, we can't make these perimeter cells sum to 9. Okay. 4 and 3 causes a gap of 2. Right, okay. Alright, I think I'm ready to start. Have a go yourselves, click on the link under the video, and with that, let's get cracking. Now, as I say, I want to look at these 39 clues because they're so much bigger than anything else, and they're sort of proximate to each other. So how do we view these clues? This is either an enormous overlap. So how do you make 39 as a sum? The minimum you could make it with is 6 cells. So if we made it with 6 cells, we'd have to have something like a 9 going across and a 6 in the other direction. Oh, but that doesn't work, does it? Because the 9 would then be always outside the sum. So just to show you what I mean there, if that's a 9 and that's a 6, we count this is the count of the overlapping cells. It doesn't include the 9. So in fact, whenever the 9 is on the perimeter, it can never count in the total. Huh. So well, what that definitely means is there's no 9 in the perimeter for this row, because we couldn't then include 9 in the count, and the only cells we can't include in the count have got to sum up to 6, and obviously 9 is greater than 6. So right, if it was not, what about if it was, it can't be 9, let's go 8 and 7. So I've got to create enough of an overlap. Is that going to work? So 8. So the overlap here is those cells. But again, these cells can't now, the outies in this sum are way over the 6 that we need. So there's no way actually this is an overlap clue. It just doesn't work. We can't get to 6 overlapping cells in any meaningful way that's going to make sense. So this is a gap clue. So we need, now hang on, if it's a gap clue, this question then is the size of the gap, isn't it? Are we leaving a 6 cell or a 7 cell gap? Because the maximum would be 7, because if it's a gap clue, we can't include the perimeter squares. But thinking about this more, if this is a 1, say, and this is a 2, then the gap is only, the maximum gap is a 6 cell gap. God, this is taking me a long time to get my head around this. But the maximum, because that whatever we put in here that's not 1 is taking up some of the gap. In fact, this is very interesting. So this has to be a 1-2 pair, which means this has to be a 1-2 pair. And what's more, there has to be a 3 next to the 2 wherever the 2 goes. So, God, blimey. So this is, which means there's a 1, 2, 3 triple in there, look, because where the 1s and 2s and the 3s are going. So this is a 1, 2, 3 triple. And ordinarily this would be a deadly pattern, because you could mix and match the direction. You know, it could either be this way round or just switch it round, and you're not changing the contents of the columns, the rows, or the boxes in doing those adjustments. But I suspect that one of the clues outside the grid will help us out here. So this 2 looks like it's going to help us out, because if these squares point at a particular one of these 2 cells, either by gap or by overlap, that will disambiguate it. So that is what this 2 clue is doing here. Okay, so what are the options then? Now, this doesn't work. You can't put the 2 in the middle of the row. Now, you may say, why not? Well, let's think about it. This clue, if the 2 was here, this now either has to be signalled as a gap clue or an overlap clue. Well, if it's an overlap clue, the only way of doing that to overlap on this one single square would be by putting 5s in both of those squares. And the only way to create a gap of 1 cell would be to put 4s in both of these cells. So actually we can do better. This is not the 2. The 2 is actually there. The 1's flipped sides. Now this 2 clue is getting even more interesting, because now it has to specifically signal this square. But we don't know whether it's signalling it by way of overlap or by way of gap. Whoa. So if this is an overlap, this would have to be a 4 and this would have to be a 6. If it's a gap, this has to be a 3 and this has to be a 5. Ah, now there's something interesting, look. There's something, I hadn't appreciated this, but that is quite interesting to me. So this is a 1-cell clue, yeah, because the 2 is solitary, it's on its own. And in signalling the 1-cell clue, if it's a gap clue, these have to add up to 8. If it's an overlap clue for a 1-cell clue, they have to add up to 10. So that's very interesting. So that means if we think that a clue is 2 cells large, say this clue across here was those 2 cells, we would then know that the perimeter cells either have to add up to 11 or to 7, depending on whether it's a gap clue or an overlap clue. Well, I don't know if that's useful yet, but that's certainly something I'm going to bear in mind. Now, how do we disambiguate this? Do I have to use this 5 clue now? So let's think about this. If the 5 clue is a single cell clue, then that's going to mean we've got to put a 5 somewhere along the row. If that's the case, obviously this can't be a 5. That would be impossible. So in the case that there is a 5 as a single cell clue, these 2 squares here have either got to add up to 10 or to 8. Now look, that's interesting. They can't add up. Well, if that's a 3. No, this is... sorry, I'm not being very articulate, but the thing I'm noticing is that actually to construct a gap clue here is tricky. Now, why is it tricky? Well, it's because of the logic I just mentioned up there, which is that if there's a gap clue, a 5 can only be a 1-cell clue or a 2-cell clue, which means that these 2 totals, these 2 cells have to either add up to 8 or to 7. Now, you can see immediately they can't add up to 7 because we can't put a 1 or a 2 in here. And they can't add up to 8 because if we make these add up to 8, I have to use the 5. And that's going to repeat the 5 in the row. So I'd have to go 5 and 3. That creates a gap in this position, but that cell would have to be a 5 because that's the clue. Whoa! So this is not a gap clue. This is an overlap clue, and it's either 1 or 2 cells. So it either sums to 10. If it sums to 10, this has to be a 4. Or it sums to 11, and that would then be either 6 or 5. So this is a 4, 5, or a 6. So now I'm looking at this clue, and I'm immediately wondering how on earth do you make 6 work here? You can't make 6 work, can you? Because let's think about this and do it in a structured way. If this clue is a 6, then if it's a gap clue, we'd have to put a very small number into this square to allow 6 to be made as a total. Sorry, 9 to be made as a total in those 2 squares. But this can't be a 1. So that's just impossible. So if this is a 6, we are definitely looking at an overlap clue. But that overlap has to include these 2 digits and whatever we put in this square. And it's got to add up to 9. So actually we'd have to have a 6 here and a 6 here, so it breaks twice. That's the only way of making this work. So all of that might not be that helpful. It means that's not a 6. Now what does that rule back out from that one then? Oh, well, if that can't be a 6, that can never be a 5. Because you can see that just from the arithmetic we've been looking at. If this is a 5, this either adds to 9, which then has no gap or no overlap, or we repeat the 5 and we have 2 5s in a row. So that's just nonsense. This now has to be 6. And that fixes this one, because that's signalling this square. We need a 1 cell overlap, so that's got to be the 4. Just wondering actually about this row now. Because if the 3 is... well, this is not 3. So this either has to be 5 or a number bigger than 6, i.e. like a 7. But a 7 is impossible because we need the total to be 3. So it's got to be some subset of these cells only that we're counting. It's either going to be a solitary 3 or a 1 and a 2, so it can't possibly include this square. So this is a 5. Now, if it's a 5... yeah, okay, so now, what are the options here? I feel like we can disambiguate this. Sorry, let me just stare at this for a moment. So, if this is a single cell clue, if this 3 is a single cell clue, these two squares would have to sum up to 10, which they can't because that's going to repeat 5. So if we are looking at an overlap, these have to sum to 11. This would have to be a 6. That would sum those two squares up to 3, with that being a 3. Whoa. Now, if on the other hand this is a gap clue, it can't be a gap clue because that can't be a 3 because there's already a 3 in the row. And it can't obviously be a 1 or a 2 either. So this cannot be a gap clue. This must be an overlap clue. This must be a 6. These are 1 and 2, and this is a 3. Good grief. I love puzzles like this. They completely make you start again in terms of your logic. You know, you can't... you know, you have to learn so much as you go through the puzzle about how the puzzle works. So, now there's a 6 here. And there's a 4 or a 5 here. So this is an overlap clue. If it's overlapping in one cell, this is a 5. If it's overlapping in 2 cells, these two sum to, doesn't give us anything. These two sum to 5, but there's no restriction at all. They could be 1, 4 or 2, 3. So if this square... so this, maybe it's this cell that we now need to focus on. Let's have a think. So, if this square, if this is a gap clue, this can only be a 3, because it can't be 1, 2 or 4. I suppose it could be, it can't be 5, because that would force this to be a 4 and there would be no gap. So, if it's a gap clue, this can only be a 3. And is that... well, and we need a 2 cell gap because the total is 9. And we... well, let me just double check that. Yeah, I mean, if this is a 5, it's obviously counting just this square, which is not enough. In fact, this just doesn't work. If this is a 3 and this is a 4, we're counting those 2 squares. This is not 3. This is not a gap clue. This is an overlap clue, which means it needs to sum up to... if it's summing up to 10, we can't use the 9 again. That doesn't work. So it's got to be a 2 cell clue or more. So it's got to sum up, this has got to be either adding up to 11 or to 12. It can't, well, that's very interesting, isn't it? So that's got to be a 7 or an 8, I think. Now let's just double check this. So if this is an overlap clue and it's a 3-cell overlap, no, it can't be a 3-cell overlap. It can't be a 3-cell overlap, because if it is, it needs the 1 and the 2 to repeat. Because, for example, if this is a 4 and we're looking at 3-cell overlap, then these two squares would have to be 1 and 2. That does not work. This has to be a 7. We're looking at 2-cell overlap, and the only possibility, therefore, of making these two squares add to 11 without repeating the 6 is if this is a 4. So these two squares have got to sum up to 9. This has got to be a 3. These squares are 5, 8, and 9 in some order. Oh, we've got a 5 clue here. Now, that might be interesting, because this square has to be an enormous number. That's got to be a 7, 8, or a 9. Well, it can't be 9, because you can't make 3 cells add up to 5, so it's not 9. If it's 8, it can't be 8, because if it's 8, we have to have a 2-cell 5 total that's those two cells, and 3, 2, and 1, 4 are impossible because of the box. This has to be a 7. So this is a 1-cell overlap, and that's a 5. I'm getting there very slowly. Sorry, guys. This is not easy for me. Now, that can't be a 5 now. There's a 5 up there. So I've used this clue now. Now I've fixed this clue as well, which I forgot about. So this is now 1-cell overlap here. And that's got to be a 5. That means there's a 5 in one of those two squares. And we get some traction on the 12, do we? 5 here. So the 12 could be... Well, it can never add to 8 or to 10, because it must be a 2-cell total. But it could be a 3-cell total. So we're looking at either... The problem is this isn't very restricted in any good way, is it? I could make that 1 or 2, or 6. There may even be more options than that, but I don't see a big restriction there. So I've done this clue, I've done this clue, I've done this clue, done this clue, this clue. Not looked at this clue. Let's just check this clue out. So we've got 3, 8, and 9 into the column there. Right, yeah, this clue is interesting, because this can't be, we can't pair up the 8 and the 9, because that's going to, we know every row of a Sudoku adds to 45. So if I have an 8-cell overlap, this cell would have to equal 24 on its own. That's just complete nonsense. So there's either... Now, I wonder if we could have a 3 and a 5. No, a 3 and a 5 doesn't work, because that obviously leaves a 1-cell gap that has to equal 21. So this is either... There's either a 3 or there's a 5 in one of these two positions. Three doesn't. No, 3 is nonsense. 3 is impossible. Because if we make this a 3, we now know this has got to be 8 or 9, and we've got to make 1 or 2. Well, we've got to make 3 cells or 2 cells add up to 21, because that's the overlap. That's not possible. 3 cells. Well, if there was a 3 here, these would both have to equal 9. So that doesn't work. We can actually say with certainty this is not a 3, and more importantly, we can say that is a 5. So now we know we're looking to here, and we've got an overlap that is either those cells or these cells that need to add up to 21. And that is all possible, isn't it? Bother. Sorry, I don't think we can do anything with that. So, have I looked at this clue? I've got 7 and 4 now, so we've got a 2-cell overlap that needs to equal 12 in those two positions, and we can't use 4, 8 or 5, 7. I haven't looked at this. That's 3 and 9. Now, that is interesting, isn't it? That is very interesting, because this can't be 9. Now, why do I think it can't be 9? Well, it's because of the restriction down here. I can't make that square, this square here, 4, 5, 6 or 7. So if it's a 1, 2 or a 3, let's make it a 3, that's the best it could be. That's summing those 3 digits. Well, I can't make 3 digits add to 28, so this can't be a 3. If we try and make it an 8, we're saying those 8 squares add to 28, which means this square would have to add up to 17. That is not possible. So this is just a 3. That's a 9. Ooh, now the 9 here, that must be helpful. That must be very helpful, because this, we now know we're looking at an overlap clue, so this has to add to 10, 11 or 12. Well, if it's a 1, clearly the clue is not satisfied, because if we put a 1 in there, this clue should equal 1. If we put a 2 in there, this has to be a 4. That looks like that works. If we put a 3 in there, this has... No, if we put a 3 in there, that doesn't work, because these 3 squares have to sum to 6, which means these would have to be 1s and 2s. And look, we'd have 3 cells that have to be 1 and 2 in the column. So this is a 2 here. This is a 2. This is a 4. That's forced. That fixes a 2 and a 1. Gives us a 4 in one of those 2 squares. 3 here. Look, that fixes that one. That gives us a 3 here. Gives us a 3 here. Gives us a 3 up there. Oh man. So now I've done... so this is now getting interesting as well. So what are the options for this square? 1, 7, 8 or 9. But if it's 7, that's pointing at a 1-cell overlap. If it's 8, it's pointing at a 2-cell overlap. If it's 9, it's pointing at a 3-cell overlap. None of those things can add to 28. That's got to be a 1. There's a 1 up there in one of those cells. 7 must be in one of these 2 positions, look. What next? So I don't know whether I'm meant to do Sudoku now, or I'm meant to do more, whatever it's called, battlefield logic. Maybe I'll just give me a second to have a look at a bit of Sudoku and see if I can see anything helpful. That's got to be 7, 8, 9. That's got to be 7, 8, 9. Look, that creates a 7, 8, 9 triple here. So this is a 1, 2, 6 triple to complete the box. I think I've looked at the 12 clue. Have I looked at the 16 clue? The 16 clue actually might be more interesting than, because this square What are the options for this square? It could be 1, it can't be 2, 3 or 4, it could be 5. It can't be 6, and we can see it can't be 6 immediately, because if it was 6, these two squares would add up to 9, and that's not possible. It can't be 6, so it's only got to be 1, 5 or 8. Well, it can't be 5, because if it's 5, these two sum to 8, and there would have to be a 1 cell gap, which can't equal 16. Now, if it's 1, we'd be saying those 5 squares need to sum up to 16 without using a 1 or a 3. No way. No, 2, 4, 5, 6, 7 blows the bank. So that's an 8. We're looking at the sum of those two squares to be equal to 16. They have to be 7 and 9, and there's a 7 there. 7, 9. Oh, it's not giving me anything. No. Those are 1, 6 and 8. I think that's all I get from that. That can't be a 1. This is a 1 up here. Is that really all I get from that? 9. Sorry if I'm missing something really clear here. I definitely feel like I should. There must be something I can do here that's going to be more helpful. Look, that square's got to be little. Well, 1, 2. Oh, it could be a 6. 1, 2, or 6. So if that's a 6, we could have a significant overlap. If that was a 9, that would force those. If this is a 1 or a 2, on the other hand, we have a problem, don't we? Houston, we have a problem. Because if this is a 1 or a 2, whatever I make this is getting far too close to it to make a 25 total work. This is not 1 or 2, this is 6. Now, does that help us? So if this is a 7 now, that's going to sum up those squares. There's probably a way of showing that that's not possible. So 8, 9 would be 17. And then I'd need 2 more squares to add up to 8. But I can't do it because 5, 6 and 7 have all gone. This is not 7. So the 7 goes here. This has got to be 8 or 9. Now, if this... So if it's summing these ones versus whatever I put in here. Now, if this is a 9, that also doesn't work because that's going to sum exactly these 6 cells, which means because we know the column total is 45, these cells would have to sum up to 20 if these sum up to 25, and they can't sum up to 20. So this has to be 8, and hopefully this will work, otherwise I've broken the puzzle. So we're now summing up these 5 cells, and I need these 4 cells to sum to 20, and that does work if I make that a 1. So that is a 1. This is not a 1, that means that's a 1, look. Still doesn't give me anything very useful. That 8 though is nice, that forces at least that to be, forces that as well. Must be an 8 here now by Sudoku. Look, in this box, that's an 8 up there. That gives me an 8 and a 9. Okay, this is getting a little bit better. 9 in one of these 2 squares. I need 1, 2 and 5 across the top there to complete the row. That can't be a 2. Ah, that must be a 2 because there's a 1 and a 5 in the column. Oh, that's going to be nice. So let's go and have a look. Yeah, let's have a look at this now. So this is comparing. So this is creating a 2-cell gap, which is appearing in those 2 squares. These 2 squares have to sum up to 12. They can't be 3, 9 or 5, 7. They've got to be 4 and 8. 4, 8 has to be in that order. One of these 2 squares has to be a 4 now. The 8 here fixes the 6 at the bottom. These 2 squares have got... Ah, these 2 squares have got to be 7 and 9. There's a 9 there. 7, 9. Ah, still stuck. Falls into one of those squares. No, it's still not tumbling over. There's 5s and 6s into those squares. These squares here have got to be 4, 7 and 9. Let's put that in. That one can't be 9. That's quite helpful though, because if there's a 4 here, this square is forced to be a 4. And this square is forced to be a 9, which means that we get the 9, we get the 1. The 5 comes over here. This is a 2, 3 pair. The 5 over here fixes the 5 down there, look. That has to be an 8 by Sudoku. Maybe we're closing in on the solution. This has to be 2 and 4, doesn't it? I think it does. So that's a 2, 4 pair. That fixes our 6, 2 over here. Sorry about this. Let me just stare at this for a second and try and work out what I'm meant to do now. So the 28 clue, what was that doing? The 28 clue. That is comparing this cell with those 3 squares, isn't it? That's interesting. Why is it interesting? Well, if we think that we know that those 5 cells there are summing to 28, these have got to sum up to 17. These have got to add up to 13 without using 9 or 8. These have to be 6 and 7, and you can see from our pencil marking the 7 is fixed, therefore. So that is very useful. Now those 2 squares have got to be a 1, 2 pair, which fixes these down here. Wow, okay, so now those squares have got to be 4, 8 and 9, and we can place the 8. These 2 squares have got to be 4 and 9. So these squares have got to be 3, 6 and 7. I'm not sure if we can place any of... Ah, we can place the 7. So this becomes a 3, 6 pair. This is a 3, 5 pair. That's not 7 anymore here. We've done the 12 clue. We've done the 25 clue. Did this clue, didn't we? What? Oh, the 21 clue. That must be where I'm meant to look now, because I don't think I've looked at that for a while. So how does this work? So we're comparing 8 and 5. These 4 squares have got to sum up to 21. We've already got 13, so we need 8 more. This is a 2 or a 3. This can't be a 1, therefore. The 1 must go up there. This has got to be a 6 or a 5. It can't be a 5. That must be a 6. The 1 fixes the 1 and the 2. That fixes the 2 and the 3. That's a 5. So now we just have to fill the middle in, and we're going to be good to go, aren't we? So that's got to be a 4, 5 pair, I think. This has got to be a 6, 7 pair. Is that right? How am I going to disambiguate this then? Ah! What have I done? What have I done wrong? Let me check. Sorry, I just checked these column totals again. 6 versus 8 is the sum of those. That doesn't affect it. 16. No, that's just those two. That was just those two. 3 and... No, that doesn't help. Ah! What am I meant to... Oh, goodness. It's... Right, okay. I forgot, when we did the 39 clues, that there was... Once you position the 1 and the 2 has to have a 3 next to it, which is outside the sum. So I could have put a 3 in there and a 3 in there, and you can see, hopefully this is going to be important. It is going to be important because it is disambiguating the puzzle, thank goodness. That's a 6, that's a 7, that's a 4, and that should be a 7. Yes. Wow. Christoph, what an idea. I mean, you and BigTiger, between you, have come up with a very interesting form of Sudoku there. And that was a lot of fun. That was not easy, though. I feel like, again, I need the wet towel and put that around my head for a while. Let me know how you guys got on in the comments, and we'll be back later with another edition of Cracking the Cryptic. Why is that square turned blue? Don't turn blue.